Hey everybody, I hope you had a great day yesterday, and we wrapped up our similar figures section of 2.5. If you have any other questions about that, please set up a Google Meet. We had that open meet yesterday. We can have more opportunities like that, but it's up to you guys to kind of reach out and ask us questions if you have them. So, we're going to move on to 2.6 here, which is using similar figures and the perimeters and areas and look at their ratios. So if you look at number 1 here, it says find the perimeter and the area of each one. So perimeter, if you remember, is the distance around the entire shape. So for perimeter of this rectangle here, it's important to remember that this is going to be 7 inches and this is going to be 9 inches. And then if we're adding up around the outside, it'd be 7 plus 7, which is 14. 14 plus 18, which would be 32 inches. And that's your perimeter. And now your area of a rectangle is the length times the width. If you remember, so 9 times 7 would be 63, and that would be inches squared. For the triangle here, the perimeter, again, would just be adding up the outside. So if I add up the outside here, 3 plus 4 plus 5 is 12. So I'd have 12 centimeters. And then the area of a triangle is 1/2 times the base times the height. So 1/2 of 4 is 2. 2 times 3 would be 6. So 6 centimeters squared. So our lesson today isn't necessarily about finding area and perimeter, but it's just a good reminder to see what the area and the perimeter of shapes are. But we're more going to focus on the ratio of perimeters of similar figures. So when two figures are similar, the ratio of their perimeters is equal to the ratio of the corresponding side lengths. So if you want to find the ratio of these two, since they're similar, we could say that one of the ratios we could use is AB to DE, or you could use BC to EF, or you could use AC to DF. And then you simplify the ratio or the fraction, and that would be the ratio of the perimeters. This will make more sense when we put numbers to it. I know it's kind of difficult when you're looking at fractions that have letters, so let's look at a problem here. It says find the ratio, red to blue, of the perimeters of the similar rectangles. So red to blue, so that means that red's going to be on top, blue is going to be on the bottom. Red's my numerator, blue is my denominator. So the corresponding sides, 4 corresponds with 6 because they're both the height of the rectangles. So I would put 4 over 6. That would be the ratio of the corresponding side lengths, which is also the ratio of the perimeter. Remember from our do now, the beginning part, that the perimeter was a one-dimensional measurement, so we just wrote centimeters, or we just would write inches. We wouldn't write squared. So perimeter is a one-dimensional measurement. That's why the ratio is a one-dimensional ratio. So 4 over 6 would be simplified to 2/3. So the ratio of the perimeter of the red to the blue would be 2/3. So why don't you take a second and look at this problem. They said the height of figure A is 9 feet. The height of a similar figure B is 15 feet. What is the ratio of perimeter A to the ratio to perimeter B? So take a minute, pause the video, give it a shot, and when you're ready, play it and you'll see the work. Alright, so if we're trying to find the ratio of the perimeter of A to the perimeter of B, what we'll do is we just have to write the corresponding side lengths in that order. So it's A to B. So A would be the numerator and B would be the denominator. So it would be 9 to 15, which we can simplify. 9 and 15 have a common factor. That common factor is 3. That would be the greatest common factor. So 3 goes into 9 3 times, 3 goes into 15 5 times, so you get 3 over 5. So that's the ratio of the perimeter of figure A to the perimeter of B. So remembering that 3 to 5 is the perimeter, right? So 3 to 5 was the ratio of the perimeters. So 3 to 5, so the ratio of perimeter A to B is 3 to 5. So from the previous example, if the perimeter of the figure A is 39 feet, what is the perimeter of figure B? So if I put this equal to 39, because 39 is the perimeter of figure A, well, I don't know what the perimeter of figure B is, so I'll put that on the bottom. Now what I can do is I can cross multiply to find out what x is. That'll tell me the perimeter of figure B. So if I cross multiply here, 5 times 39 and 3 times x. So 3 times x is 3x. 39 times 5 would be 195. So divide both sides by 3. And then we get x equals 65. 65 feet is the perimeter of figure B. So that's what this is used for. So going back, just a refresher. So the perimeters of similar shapes, there's the ratio. The ratio is the same as the ratio of the corresponding side lengths. So we use that to find out the ratio of two side lengths. That wound up being the ratio of the perimeter. And then we can use that information to find an unknown perimeter. Alright, so that's what we can use this for. Now we can also find areas of similar figures as well as perimeters. It's a bit different though. So, area is a two-dimensional measurement. That's why when you find the area of something, you call it centimeters squared or inches squared. So area is a two-dimensional measurement because of that. So if we want to find out what the ratio of the area is, you find the corresponding side lengths, you put them as a ratio, and then you square them. So that's what it looks like here. So when we're doing perimeter, the ratio is AB over DE. Well, now the ratio of the areas is AB over DE squared. It's best to show you with numbers, and then I think it'll make the most sense. So it says find the ratio, red to blue, of the areas of the similar triangles. So red to blue. So red is in the numerator, blue is in the denominator. So you have 6 over 10. Now one thing I would suggest first is check to see if you could simplify the fraction before you square it. Because you can square it now, of course, but your number is going to be bigger. If it's possible you can simplify it, then you'll have smaller numbers. So 6 over 10 can be simplified to 3/5. So that's the ratio of the corresponding side lengths from red to blue, 3 to 5, because it's 6 to 10. So now to find the ratio of the areas of the similar triangles, we will now square them. So when we're squaring a fraction like this, we square the numerator and we square the denominator. 3 squared is 3 times 3, which is 9. 5 squared is 5 times 5, which is 25. And that is the ratio of the areas of the similar triangles. We could have gotten the same answer if we just squared the original. If you squared the original, it would have been 36 over 100, and then you would have just had to check to see that 4 goes into both of them and then simplify it from there. But it's a little bit easier to simplify it before you square it. So we have this problem here. It says the base of triangle P is 8 meters. The base of a similar triangle Q is 7 meters. What is the ratio of the area of P to the area of Q? All right, so we have the base of triangle P is 8 meters, and the base of a similar triangle Q is 7 meters. So it's the area of P to Q, so that's why we have P on top and Q on the bottom. Now 8 over 7, I can't simplify that. Now 1 and 1/7, you might be saying to yourself, would be simplified, but we don't need to write it as a mixed number, just leave it as an improper fraction. So 8 over 7, we'll leave that like that because we can't simplify it any further. Since we're talking about the ratio of the area, we're going to square it. So 8 squared is 64, and 7 squared is 49. So the ratio of the areas of P to the area of Q is 64 over 49. This can't be simplified, so that's as far as it goes. Alright, so that's what we're going to do for today. So if you go to Big Ideas, there's a couple questions there. If you have any questions from this video or about this topic when you're doing the Big Ideas, please reach out to me. If you're completely stuck, reach out. We'll set up a Google Meet. I can share my screen. We can do the Big Ideas together. I have no problem with that. So please just reach out if you're not sure about this lesson. Alright guys, have a great day. We'll talk to you soon.